Welcome to this PowerPoint presentation on AC theory. Before we start with AC theory, let's go through some of the definitions that we'll come across whilst discussing AC theory. We have peak value, and this is where an AC generator has rotated for 90 degrees. The loop is cutting the lines of magnetic flux at its maximum, therefore producing maximum EMF. And we'll demonstrate this on the next slide. Peak to peak is the voltage or current measured between the positive and negative peaks. To find the total peak to peak value, we would generally multiply the peak value by 2. On the horizontal axis we have 3 symbols. One is degrees, second one's time, and the last one's frequency. And these can be used to measure an AC sine wave during one revolution. We have one cycle or period, and this is the time taken to complete one revolution. We also have instantaneous values, and this is the reading taken from the sine wave at any point in time during its cycle. And then the last thing is the y-axis, where we have but this is used to measure voltage or current. Here we are generating an AC sine wave. We have a north and a south pole, and we have a loop of conductor rotating inside this magnetic field. And what we're going to do is actually show you how we generate electricity. So as the loop rotates around to 90 degrees, you'll see that the conductor is cutting the magnetic field at its maximum point, and that's where it generates its maximum EMF. So as it rotates round, at this point now, it's actually producing generating its maximum EMF. And then this continues and happens in that point there at 270 degrees in the opposite direction. So if we want to, what we're going to look at first of all is the instantaneous values. If we wanted to obtain a reading from the sine wave at any point in time during its cycle, this would be classed as the instantaneous value. And the formula is maximum peak multiplied by the sine and the degree we are looking at to find. So here's an example. If the supply peak voltage is 120 volts, what is the instantaneous value at 47? And as you can see on the left hand side, I've circled the sine function button. So if you were to put this into your calculator, you should come up with a value. If you want to work this out, you can pause this presentation to work it out, and then continue the presentation to find out if you got your answer correct. So this answer here is 87.76 volts. Okay, so the reason for doing the instantaneous values, it allows us to plot a sine wave. So what I'm going to show you here is with this red line, which is at 0 volts at the moment, as it rotates around the magnetic field, so as it loops round in a circle through the magnetic field, you'll see that at 90 degrees is where it cuts the magnetic field at its maximum, and therefore producing the most EMF. And then it will rotate back down to 0 at 180 degrees and do the opposite in the opposite direction. So as you can see, 90 degrees and back to 0. So one of the values that or one of the items you'll be asked to find out is the average value. To find the average, we would add all the instantaneous values and then divide it by the number of values used. As with any average, the more values used, the greater the accuracy. For a sine wave only, the average value is equal to the maximum value multiplied by 0.637. As a formula, this would look like the maximum peak value times 0.637. Another quantity we would find in an AC sine wave is the root mean squared, also known as the RMS value or the effective value. To measure power, the RMS method of measuring voltage and current was developed. If we were to measure at a distribution board for voltage, we would be measuring the RMS value. So what this is defined as the AC value of an equivalent DC quantity that would deliver the same average power to the same resistor or load. So when current flows in a resistor, heat is produced. However, an alternating current having a maximum peak does not maintain a constant value. The alternating current will not produce as much heat in the resistance as with a direct current with the same peak. So let's have a look at this in the following diagrams. On the left hand side, we'll see a supply running at 230 volts, which is being run constantly. The second diagram shows that it's only peaking at 230 volts every 50 times a second. Now, as you can see with the shaded area, this is shows how much heat is being produced, and as you can see on the second one, it's a lot less than the first one. Therefore, to get the same equivalent DC output from an AC supply, we have to increase the peak voltage, as demonstrated here. So as a class example now, let's work out the RMS value if the peak voltage is 325 volts. What is the RMS? And again, you can pause this PowerPoint to find out the answer. The answer is 230 volts. So, another thing you would have to find out from an AC quantity is frequency and period. To find this out, we can use the following formulas. So to work out frequency, it's 1 divided by time, and to work out time, it's 1 divided by frequency. Bearing in mind though, this is based on just one cycle, so the completion of one cycle will determine how much frequency is being produced. Okay, let's have a look at this example. Again, pause this PowerPoint to have a go at these questions. Then once you're happy with all the answers you have, continue playing. So the peak to peak value can be worked out by multiplying the peak value by 2 to give us 90 volts. The average value can be worked out by multiplying the peak value by 0.637 to give us 28.67. The RMS value can be found by multiplying the peak value by 0.7071 to give us 31.82. The instantaneous value at 45 degrees will also give you the same value as the RMS. So you should have 31.82. Handy tip to know for your exams. And the frequency can be worked out by doing 1 divided by 0.05 seconds to give us 20 Hertz.